Alright, so this is chapter 4.5. We are writing equations that represent functions. Today we're not focusing on just getting the answer, we're focusing on writing an equation and then finding the answer. I thought this was a great first problem to go over, so I want you to pause this video and read it. I'm going to highlight the information that I feel is important. So you and a friend are swimming 20 laps at a local pool. One lap is across the pool and back. You both swim at the same rate. Your friend started first. The trail of arrows shows how far he has swam. Now this says swum, and I'm not sure if that's true or not, if it's swum or swam, but I'm going to say swam. We'll have to ask Miss Alesso about that. What equation gives the distance you have swam as the function of the number of laps your friend has swum? How far have you swum when your friend finishes? So we have two questions. What equation and how far? Explain your reasoning. Now I'll explain my reasoning through words, and you would use this part to actually write down your reasoning. In previous sections we talked about variables, and I'm going to have two variables here. Now it doesn't say what variables to use, so I'm going to use d for distance, and I'm going to use L for laps. Now notice we have to write an equation that gives the distance you have swam as the function of the number of laps your friend has swam. So right now, here's you and here's your friend. You have your friend has swam one down and back lap, which is 25 meters down, 25 meters back, so that's 50. And then right here it tells us that this person swam another 15 meters before you started. So I already know that my friend has already swam 65 meters. So I know that I will always be 65 meters behind him because he started earlier. Now we have to write our equation where distance is affected by the number of laps. So if we both started at the same time and we swam at the same rate, it'd be really easy to write this function rule. It would be d, which is the distance, equals 50, because that's what a lap is. A lap down and back is 50 meters times however many laps we swam. Now this would be our function rule if we both started at the same time, but unfortunately we did not. So I'm going to use d equals 50 times L, but remember this is a function talking about my distance but using my friend's laps. So I would take this part, 50 times L, and subtract 65 from it. Now why would I subtract 65? Because I will always be 65 meters behind. Now it's really easy to see where or how far I have swam when my friend finishes, because now all I have to do is take my equation, which is 50 times L minus 65, and now I just got to plug in the distance, the laps, which I know that I'm going to swim 20 laps. So if I do this, I can put this in my calculator too, but this is 1,000 minus 65 equals the distance. So that means we're talking about meters. It asks you how far have you swam when your friend finishes. So this should make sense to you because you are done when you swim 1,000 meters. Now your friend is already done, but when you still have about 65, because 1,000 minus 65 is 935, you have swam 935 meters, so you are not done yet. So basically this is our answer and this is our equation. Let's try another one. Carolyn has 420 CDs in her collection. Each month she adds 12 more CDs to her collection. What equation is a function rule that represents this situation? So I'm going to use x equals and y equals as my two variables. Y is going to equal my total number of CDs because that's what we're trying to figure out. So total number of CDs. And the total number of CDs, which is the dependent variable, depends on x, which is how many months you take into account that she adds 12 more CDs. So this would be the number of months. So when we're writing let's split these up. So when we're writing a function rule, we would say that the total number of CDs equals, well, I know Carolyn has 420 CDs, but she adds, which is plus, 12 more CDs to her collection each month. So that would be 12 times X. Now, why would it be 12 times X? Because each month, X is the number of months. If it was 2 months, she would add 24. If it was 3, she would add 36. If we're talking about the first month, it would only be 12. So this would actually be our function rule, because this is what represents the situation above about Carolyn adding CDs to her collection. Let's move on to this next story problem. An archery club charges an annual membership fee. So if you guys don't know what annual means, that's once a year membership fee of $65 plus $2 per visit. Now, per is also a very important, almost like 12 more CDs each month. Write a function rule for the total cost of belonging to the club if you make V visits. So they do give us a variable this time. How much would it cost if you use the club 15 times in a year? So if you notice, they're asking us two questions, or asking us to do two things. Write a function and then find out how much it would cost. So before we do anything, we have to find what the function is. So I only got V here, so I know V equals visits, and let's just call the other one T, which is the total cost. So I know that my total cost is going to equal $2 for every time I visit, so 2 per visit, so 2V. Now, it's not just $2 every time I visit, it's $2 every time I visit plus that $65 fee that I had to pay right away. So really, they're asking you how many times, if I go to the club 15 times in a year, some of you might just think, oh, that's not a 2, that's a 12. 2 times 15 equals $30. That's not necessarily true, because you forgot about the $65 you have to add on to that for that membership fee. So to solve, this is actually our function rule. And then all we'd have to do to solve this is plug in the number of visits, which is 2 times 15 plus 65. And we already know that 2 times 15 from our work over here, 2 times 15 is 30. And then we have to add that $65 membership fee. So our total amount of money that we spend is $95 in 1 year. Okay, so we have a little geometry question here. We're talking about rectangles, so I'm going to make a rectangle right here. Write a function rule for the area of a rectangle. Right away, I should know that the area of a rectangle is the length times the width, or base times the height. Same thing. Area of a rectangle whose length is 3 inches more than the width. So let's just do an example here on the side. If, let's say, so the length, let's just label this is our length and this is our width. Okay, so if the length is 3 inches more than the width, so that means if the width was 3, you would have to take 3 more than 3, and that would mean that the length is 6. So that's kind of what we're going to be trying to figure out, but they don't give us numbers right away, so we have to write that function rule. So I'm just going to label like I did before, this is length and this is width. Now what do we know? We know that the length, which is right here, is 3 inches more than the width. So basically, another way I could say that what the length is the length is actually the width, whatever the width is, plus 3. Now, some of you would think that it would just be easy, hey, now I just got to solve this. But they said, what is the area of the rectangle when the width is 7 inches? So if I try to figure this out without writing a function rule, I would have A equals L times 7. That's an issue because I have two variables. So basically, I'm trying to get rid of one of the variables so I have I have the same variable in both parts. So basically, I can erase this or cross this L out, and W plus 3 means the same thing because up here it says the length is 3 inches more than the width. So now I have W and W plus 3. So now instead of writing L, I can substitute W plus 3. So I'm going to write W plus 3 times W. Now look, 2 W's, that's it. I don't have any L's, so now I only have one variable. So now I can distribute here because we have times a W, so we have to distribute that. A equals W times W is W squared plus 3 times W is 3w. Now look what we can do. What is the area of the rectangle when its width is 7 inches? Now if I plug in 7 in my equation, or in my function, I just have to plug it in here and here. So that means that we have A equals 7 squared is 49 plus 21. A equals 49 plus 21 is 70. Now we would not have been able to solve this if we just left this as L. Because how can I figure out the area of a rectangle when I only know that this equals 7? So 7 times L equals the area. I can't figure that out. So I need to try to figure out a way where I can get rid of this L and maybe put in a W so I only have one variable to work with. So again, it says write a function rule for the area of a rectangle whose length is 3 inches more than its width. That was this part right here. A equals W squared plus 3W. Could you leave it like this? No. You need to distribute and simplify it to this. So this is the first part of our answer. Then it says what is the area of a rectangle when its width is 7 inches? I was able to plug in, oh, well, I guess we have Miss Erickson's birthday here, so we're going to have to get rid of that email. And so anyways, 7 squared plus 3 times 7, which means, notice we only have two W's, W here and a W here, so we evaluate or plug it in. We plug in 7 for W, and we get the area equals 70.